In this lecture, we are going to talk about some more important terms that we come across in the finite element analysis or finite element method, right? So, boundary conditions. This is the most important thing that one should know when they are dealing with the technique of finite element method. So, just simply defining boundary conditions, they are nothing but the application of various kinds of loads or constraints which can simulate the physical environment of the object. So this is what are called as boundary conditions. So see here, boundary conditions are divided into two types. One is the constraining conditions, the second one is the loading conditions. Using the combination of constraining conditions and loading conditions, we will try to simulate the environment in which the body is present or in which the body has to be tested. See, for example, here we are going to apply the constraint condition, and to simulate this particular force we are going to use a loading condition, right? So this is what are known as boundary conditions. Simply constraining conditions and loading conditions, and using boundary conditions we will try to simulate the environment in which the object is going to operate or stay in. Now, there are different types of loading conditions. Let us say concentrated load, let us say point load, then a force load on a line or an edge, then pressure, which is nothing but application of force over an area, and this is somewhat equivalent to the distributed load. And even in the distributed loads also there are different types of distributed loads like uniformly distributed load, uniformly varying load, and varying load, and other types. Then in addition to all of these things, we have something called as a pressure and vacuum, gravity loading, centrifugal loading, hydrostatic loading, bending moments, torque, temperature loading, and additional types of loadings are also available. And most of the times, remember, we are not going to use a single type of loading condition, but we will use a combination of different types of loading conditions to simulate the environment of that particular object. Then coming to the constraints, any type of constraint can be easily simulated by restricting a combination of these 6 degrees of freedom. As we already know, in universe or in space we have 6 degrees of freedom. They are translation in X, translation in Y, and translation in Z. Likewise, the rotation about X, rotation about Y, and rotation about Z. Based on the combination of fixing these particular degrees of freedom, we can simulate any type of constraints or supporting conditions in the entire universe. Let us say you have fixed the 1 degree of freedom, 2 degree of freedom, 3 degree of freedom, which is nothing but translate about X, translation about Y, and translation about Z. This thing is called as a fixed translation constraint. Then if you leave this degree of freedom 1, 2, and 3 free, but fix up this 4, 5, 6, then it is called as fixed rotational constraint or fixed rotational boundary condition. So what will happen? Let us say if I apply the fixed translation constraint, that means the object cannot move in X direction, Y direction, as well as Z direction, but it can easily rotate about X, Y, and Z. Likewise, if I take the fixed rotational constraint condition, what will happen is this cannot rotate about X, Y, or Z, but the object is free to move in X direction, Y direction, and Z direction. Then the third case is if I fix all the degrees of freedom, it is called as a fixed constraint. It is called as a fixed constraint where the body is not allowed to either translate or rotate about any axis. Now, we'll take an example of a cantilever beam which is fixed here and a load L is applied here. So what we are going to do is, using the process of meshing, what we will do is we will convert this into nodes and elements, and once we convert this into nodes and elements, the next thing is here I need to apply the constraint. So I will apply the fixed constraint here as this is already fixed. And now I have to apply the load, so I will be applying the load which is uniformly distributed on all the nodes. So this is what I will convert this physical system into in terms of FEM, and then using this I will create the equations in the form of F equal to kx, and then I am going to solve these equations using iterative methods and find out the displacements. And once I find out the displacement at each and every node, I will be able to calculate the required stresses and strains. So this is how I will convert the physical system using the boundary conditions into a FEM model or finite element model. Okay, now we will see different types of constraining, right? So for that we will consider an example. See here, there is a steel bracket which is attached to the wall, and a force is being applied here at the free end. So in the first case, what we can do is we are going to take the top hole here and fix the hole, and we are going to apply the force at this particular hole as shown in the system. Then what will happen is, see here, this particular model is showing a displacement of 55 mm as well as the stresses which is nothing but 1682 MPa. So here if you observe, this entire model has not properly been constrained, or otherwise this model has not been applied with required constraining conditions. That is why it is known as the under constrained boundary condition model, and due to which what will happen is we will get very high amounts of displacements as well as the stresses, right? Then the next case is over constraining. So now what we are going to do is, instead of fixing up the only this hole, we will fix the entire face and then we apply the force here. So this particular condition is nothing but over constraining, so applying constraints more than the required. Now if you see, we are getting very less displacement as well as somewhat less stresses when compared to the under constraining condition. Now the third condition is nothing but sufficiently constrained model, and this is what we need to target. Whatever the model we are going to do, we need to create sufficiently constrained model. We should not create over constrained model or under constrained model. You need to remember that. Now what is happening is, suppose in this particular model, what we did is, in addition to this particular hole being fixed, we also have fixed this particular line, and we fixed only translation of this particular nodes on the line, and we applied the force. So what happened, this is what is creating something called as a sufficiently constrained model, and this is where we are going to get most appropriate results when compared with the previous two cases. So remember one thing, always try to go for the sufficiently constrained model, right? So this is a basic brief introduction about what are boundary conditions, loading conditions, constraining conditions, how to create different constraining conditions, and what are known as under constraining conditions, over constraining conditions, and sufficiently constraining conditions.